Hello students, today we'll be looking at the topic, the periodic table. The periodic table. We said that the periodic table is an essential tool in chemistry that organizes elements based on their property. Having said that, what is periodic table? We said that periodic table is a table that contains the arrangement of chemical elements in vertical columns called the group and in horizontal row called the what? The period. That is what? The periodic what? Table. Then we quickly look at brief history of the periodic table. Now, the periodic table was constructed by a Russian scientist called Dmitry Mendeleev. in 1869. Yes, the periodic table was first constructed by a Russian scientist called Dmitry Mendeleev in 1869. He classified or he arranged elements in the order of increasing atomic mass, followed by Henry Moseley in 1913, followed by Henry Moseley. What this young man, Henry Moseley, what he did was that he revised what Dmitry Mendeleev stated or what he constructed. And according to Dmitry Mendeleev, he arranged these elements in the periodic table in the order of increasing atomic mass. But Henry Moseley arranged the elements in the order of increasing atomic what? Atomic number. What is the difference here? This first one, Mendeleev arranged in the order of increasing atomic mass, while Henry Moseley arranged in the order of increasing atomic number. Do you understand? What is atomic number and what is atomic mass? When we talk about the atomic mass, we're talking about the addition or the sum of proton and neutron. When you add proton and neutron together, what you get is what is your relative atomic mass, which is what I normally call atomic mass. Now, what is, according to this guy used what? In the order of increasing atomic number. What is atomic number? We say that atomic number is the number of protons present in an element. So that is just the difference between these two. But other scientists that contributed in the arrangement of the periodic table, we have Dobrina, we have John Newland and others. I talk about Dmitry, Henry Moseley, Dobrina, John Newland. There are other scientists, but I focus mainly on these two. Having said that, now we quickly look at the modern periodic law. What does this law state? The modern periodic law states that the properties of an element are the periodic function of the atomic numbers. Having said that, we now quickly look at description of the periodic table. Now we want to describe in details the periodic table, mainly for SS2 students. Now, description of the periodic table. We want to talk about the full description of the periodic table. Now, the periodic table, we have the full periodic table, which the one that contains element 118, about 118 elements in the periodic table. That is the full periodic table. Then we also have the first 20 elements periodic table, of which you must have been told when you were in GSS3. Yes, GSS3, the first 20 elements, SS1, first 20. But from SS2, you should get used to the complete periodic table. Now, for the first 20 elements, we have something like this. Now, we now have period 1, period 2, period 3, period 4. Then we have this. Then group 8 is also called group 0. So we now have hydrogen, we have helium, we have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Then we have sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Now, this is the first 20 element periodic table. This is the first 20 element periodic table, the first 20 element periodic table. Now, if you look at it, I have G all over P here. This is group over period, group over period, group over period. Then the vertical lines, these vertical lines, the one in Roman figure, the one in Roman figure, this one, these vertical lines, the vertical lines are the group. The vertical lines are the what? Are the group. While the horizontal lines are the what? Are the period. This is for this first 20 elements, we have period 1, period 2, period 3, period 4. Period 1, 2, 3, 4. That is for the first 20 elements. But for the full periodic table, that is for the full periodic table, that is the total about 118 elements. We have 7 periods. This is going to be 1, 2, 3, 4, 5, 6, 7. That one will have 7 periods. Then the group, which is the vertical columns, the group is going to be 18. We are going to have 18. So this is going to be 7, 18. But for this one now, this is group 1, this is group 2, group 3, group 4. Then we have hydrogen, helium, hydrogen, lithium, sodium, potassium. These are group 1. Then for group 2, we have this group 3. This is a short demonstration of the word of the periodic table. Now, this one will not take us to the complete one. The complete one, where you have something like this. You must have seen this. Then you now have another one here. This is the complete periodic table. If you have seen this one, okay. Don't turn your camera. Just okay. Before I show you this diagram, now take a look at this. Okay, take a look at this diagram. This one is the complete periodic table. Here, look at the number of periods. Period is period 1, 2, 3, 4, 5, 6, 7. It has 7 periods. Then the group, this row, the horizontal row, this horizontal like this is the word. The row like this is the period. This is period. Look at, okay. This is period. This is period. Period. This is period. Period. Then why the vertical like this is what? Is the group. The verticals, they are the group. While the horizontal like this, they are the what? They are the period. We have period 1, period 2, period 3, period 4. We have group 1, group 2, group 3, group 4, group 5, group 6, group 7. So, same thing with this one. This is group 1, group 2. 13 here is group 3, group 4, 5, 6, 7, 8. But since this is the complete periodic table, we say group 1 to group what? To group 18. Now, when you get to this is group 1, group 2. From this group 3, you can see the group 3 is not on the same level with this one, but it was brought down because they are the transition metals. They are the transition what? Metals. This is their transition metals. Then this continues from here, group 13, which is group 3 here. Look at it, group 13 here. Now the first one you have boron. That is group 13, which is group 3. Look at it, 1, 2, group 3, you have what? Boron. Group 4, you have carbon. If you check this part also, group 14, you also have carbon. So this is 1, 2, 3, 4, 5, 6, 7, 8. You see this from this, you see this part, this group 3 to this group 12, they are the what? They are the transition metals. Okay, now let's quickly look at the description of the periodic table. So here we have, this is group 1, sorry. Then this is group 1, this is my group 2. Then this is 3, 4, 5, 6, 7, 11, 12, 13, are seeing here, this is group 1, this is group 1, group 2, this is group, they are these verticals, they are the group. Then this is 1, 2, 3, 4, 5. This one is up to 7. It's up to 7, but I did not complete it. It's up to 7. So this is 1. This is period 1, period 2, period 3, period 4, period 5. These are period. The horizontal rows, these horizontal rows, they are the period. While the vertical are the what? Are the group. Having said that, this is the periodic table is also classified into S, P, D, and what? And F. So group 1 and group 2, this group 1 and group 2, they belong to what? To S block element. They belong to S block. Group 1 and group 2 belongs to S block. Then 13 to 18, that side is the P block. This is the P block. P block begins from boron, carbon, nitrogen, oxygen, fluorine, neon. This is your P block. All elements here they are the P block elements. While elements in group 1 and group 2, they are the S block elements. The elements here are S block. Then you see these parts written in blue ink. This part, this is the transition element, and which is called the D block. This is my S block. This is my P block. Here is my what? D block element. Then the D block elements are called the transition what? Element. They are the transition what? Elements. So we have the scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. That is the first transition element. So the D block, this is my, if you are asking your school, give me 2 examples of D block elements. All the elements here written in blue ink here, they are all transition what? Elements. And transition elements are the D block elements. Then we have the P block elements it's on the right side of the periodic table, that is the P block. While the left side, which is group 1 and group 2, they are the what? The S block, where you have the hydrogen, lithium, beryllium, sodium, magnesium, calcium, rubidium, strontium. All these are the what? The S block element. Then the last one is the F block element. Here is the F block element. This is the F block element. The F block elements are the nathalines and the what? And the actinide. They are the F block element. Look at it. Nathalines, they are outside the periodic table. Down part of it, the F block, nathalide, and the actinide, the D block, the S block, and the what? And the P block. Having said that, this S block element comprises of the alkaline metals and the alkaline earth metals. You know, I told you that S block are group 1 and group 2 elements. Now, these same group 1 and group 2 elements, they have their own name for their group. Group 1 elements are called alkaline metals, while group 2 elements are called alkaline earth metals. Do you understand that? Then we now move on to group 1 is alkaline metals, group 2 is alkaline earth metals. Then group 7, they are the halogen, which means salt formers. Halogen, group 7, they are halogen. While group 8, they are called the noble gases, or rare gases, or inert gases. Those are the 3 names you can call them. The noble gases, the rare gases, or the inert gases. That's for group 8. What about group 6? What is the name for group 6 element? Group 6 elements can still be called the chalcogens. The chalcogens. So that is what you can call group name. That is the oxygen family, the chalcogens. They are just the family. Group 6 can be called the chalcogen. Group 7 are halogen. Group 8 are the noble gases. Group 1 is the alkaline metals, while group 2 are the alkaline earth metals. So that is a few description I have on this video for this periodic table. Then lastly, we now look at number 5, which is the periodic trend. What are these periodic trends? We say that periodic trends are the variation or changes in the properties of elements across the period and down the group in the periodic table. And what are the examples of these periodic trends? Number 1, we have ionization energy. We have ionization energy, we have electroaffinity, we have electronegativity. Let me list them. Okay, now this is the periodic trend. The periodic trend are, we have the, either you call it the periodic trend or you call it the periodicity, same thing. The periodic trend, we have ionization energy, electroaffinity, electropositivity, electronegativity, metallic properties, and atomic radius, and others, even electrical conductivity is part of it. Now, ionization energy is the amount of energy needed to remove an electron from an atom in its gaseous state. Now we have first ionization energy, second ionization energy, and third ionization energy. So the amount of energy required to pull one electron or to remove one electron from an atom is first ionization energy. To remove two electrons is second ionization energy. To remove third electron is third ionization energy from an atom. Now, what is the periodic trend of ionization energy? When you move from left to right across the period, ionization energy increases. It increases. And when you move from top to bottom down the group, the ionization energy decreases. Let me quickly illustrate that. Now, look at lithium. The electronic configuration for lithium is what? The electronic configuration for lithium is what? Is 2 1. 2 1. Then that shows that if you draw the share, lithium has just 2 shares. The innermost one has 2, the outermost one just has what? 1. So the amount of energy, which is the ionization energy, the minimum amount of energy required to remove this valence electron from this lithium is going to be low compared to, let me use neon. Neon, the electronic configuration for neon is 2 8, that is 10. Draw the electronic configuration. The innermost one is 2, then the other one is what? Is 8. Is 8. It will be difficult for you to pull one out of this 8 compared to this one. That is why we say that for you to be able to remove one from this neon, you need a higher amount of energy. That is why we say that the periodic trend is that ionization energy increases from left to right. It increases. While when you go from top to bottom, which is down the group, it decreases. Why? Because if you go down, the number of shares keep on increasing. Ionization energy increases from left to right because the forces of attraction between the valence electron and the nucleus is what? Is closer. That is another reason than in group 1 or group 2, because the forces between the valence electron and the nucleus is what? Is weaker because of the distance. Then we now quickly look at electroaffinity. Is the heat evolved when an atom gain electron. Electroaffinity is the heat evolved. It's an isothermic reaction. Is the heat evolved when an atom gain electron. Then moving from left to right, electroaffinity increases. Moving from left to right across the period, electroaffinity increases and decreases down the group. Then the third one is electropositivity. Electropositivity is the ability of an atom to lose electron. The ability of an element or an atom to lose electron. That is electropositivity. Moving from left to right across the period. Moving from left to right across the period, what happens to electropositivity? It decreases. It decreases from left to right and increases from top to bottom. That is down the group. It increases. I come again. Electropositivity decreases from left to right and increases down the group. Then the other one is electronegativity. Electronegativity is the ability of an atom to attract electron to itself or to gain electron from another atom. So electronegativity increases from left to right. Electronegativity increases from left to right across the period, that is the periodic trend, and decreases from top to bottom, that is down the group. Then number 6 is the metallic properties. We have said that metals are substances that conduct heat and electricity. We also said that metals are substances or elements that ionizes with what? With electron loss. That is metal. Now what is the last one, which is the atomic radius? Then atomic radius actually talk about the distance between the valence electron and the nucleus of the what of the atom. That is atomic radius. So moving from left to right, atomic radius decreases from left to right, and atomic radius increases down the group. So that is it for this video. Do well to subscribe to my channel. Thank you very much and God bless.